Which of these is energetically favored? That is, which of these reactions produces a compound that is energetically favored? Remember, there is nitration of benzoic acid, and here the nitro group is attached at the ortho position. Here, the nitro group is attached at the meta position. Which of these two compounds are energetically favored, are more stable, or more eager to be formed? You know, which of these reactions is possible? Indirectly, the question is saying, is COO group an ortho-para director or a meta director? Remember, if it is an ortho-para director, any O2 being here is energetically favored. It can also be here, ortho-para. But if it is meta director, any O2 must be at the meta position. So let us use canonical structures. Let's generate the canonical structures of the products and know if we have any canonical structure that is energetically not favored. That is a canonical structure that is highly unstable or too unstable to exist. So let's check reaction A. Now, this benzoic acid is ready for reaction. Remember, the carbonyl carbon has a partial positive charge because of this carbonyl oxygen. This oxygen is highly electronegative, so it abstracts the bonded electron towards itself to become partly negative. So this is ready for reaction. But the NO2 will come in form of NO, nitroxonium ion, which has positive charge. So this pi electron moves into this positive charge, and it will break, and we have a canonical structure. We have this canonical structure. So the NO will now be at ortho position with a H here. You know, there are H here, but I prefer to show this particular H. Now, when this bond broke, it will leave this carbon with a positive charge. Once that happens, this bond will now move into this place in order to annul this positive charge, and we will create another canonical structure. Partly negative, partly positive. Bond will now form here, and we will create the positive charge will move to this place. Since this bond is now here, this carbon is satisfied, but this carbon will now have the positive charge. Our NO is here, H. Because of this bond will move into this place to re-establish itself here and annul this positive charge, and because of that, we will have another canonical structure. Partly negative, partly positive carbon. The bond will be here and here, which means the charge will now be on this particular carbon, NO, H. You can see that there is no going further again. There is no going further. This bond cannot move into this place because oxygen is too electronegative to allow that to happen. So finally, we have three canonical structures. But the final product will always be the oxidized product in the presence of this acid, and which is this. Okay, let me do it this way. These are the canonical structures. So the final product will look like this. The final product without any charge now. You know, the product will be like this, NO2, because this is oxidation, and H. Reaction B, where NO is directed to the meta position. So the bond moves into this place, and we have a canonical structure, creating a positive charge. Okay, NO here now, H, positive charge here, COOH, partly negative, partly positive. So because of this bond moves into this place, and we have another canonical structure, OH, partly negative, partly positive. And we have a new bond here, establishing positive charge here, NOH. Because of this bond moves into this place again, moves into this place to annul the positive charge, and we have another canonical structure. So the bond will now be here and here, establishing positive charge here, NaOH. So, no going further again. Consider the relative position of this final plus positive charge and the partial positive charge on the carbon-I-carbon. Very far. This one now, you have to pass this carbon before you reach the carbon-I-carbon. So the two positive charges are very far too. Also here, they are far. So these three canonical structures are energetically favored. But here, for auto nitration, this positive charge and this one, they are very close, making it energetically not favored. Therefore, reaction B is energetically favored. And that is this reaction. It's energetically favored.